These are the 1.4 notes covering circles. So the equation of a circle looks like this. X minus h squared plus y minus k squared equals r squared. The center is what represents the h and the k, and the r is the radius. So how do I graph a circle? Anytime we need to graph a circle, you need to make sure you know the center and the radius. Now, with the center, the h and k, if you look up here, it's the opposite sign with that minus. So just make sure you change the sign of the h and k as you pull it from the equation into the ordered pair. We are also going to need to square root the number to get the radius. So example number 1, your center should be 5, negative 2, and your radius should be 3. Okay, so once we have the center and the radius, we're going to plot the center, 5, negative 2. And then the radius, we're going to go 3 in each direction. So 3 to the right, 3 to the left, 3 up, and 3 down to create the circle. For example number 2, center is going to be positive 4. And then since there's nothing here on that y squared, it's just going to be a 0. Square root the 25 to get 5. Plot 4, 0, and then go 5 in each direction. And then draw your circle. For the next part, you're going to actually work backwards. So instead of being given the equation, you're going to be given the information, the center and the radius, and you're going to have to write the equation. So for example number 3, same things, just make sure you change the signs of the h and k again. And when we put the radius back into the equation, you want to make sure you square it. So square the r to put it back into the equation. Okay, so this first one is going to be x minus 5 squared, y plus 8 squared. Notice we changed the signs of the h and the k. And then we're going to square the 2 to get 4. Example 4, I'm just going to write my x squared without any number because that's 0. So I can just write it as x squared plus y minus 3, change the sign. I'm going to square that. Oops. Not cube it, square it. Square that. And a square root and a square cancel out. Just leaves me 3. Example number 5. My center is given to me as 2, 1, this point right here. I just need to be able to find the radius. So for the radius, I just have to figure out how far it is from the center point to there, which if this point, the center is at 2, 1, and this side point is at 0, 1, that is a distance of 2. And then you can write the equation. Change the signs of the h and the k, and square the radius to get 4. On the back side, we've got some more complex writing equations. On problem number 8, they're giving us the endpoints of the diameter. So we know a diameter is when it goes all the way through the center of the circle from one side to the other. And they're going to give us the endpoints. So imagine it like they're giving us that point and that point. So I'm going to plot those two blue points. So 4, 3, and 0, 1. And you can draw the diameter through it. Then we're just going to very carefully make a little circle around it. This is going to be an approximation. Something like that. So anytime we are trying to write the equation, we need to make sure we know the center and that we know the radius. The center you can find just from looking at it. The middle of those two blue dots would fall right here, which looks like the point 2, 2. The radius is a little bit different, so we cannot count diagonally on a grid. So we're going to imagine a very small triangle right here and right here, and that's going to help us then find that hypotenuse. So on this little triangle, I've got this is 2, and then this side over here is 1. So we can do 2 squared plus 1 squared equals c squared. 4 plus 1 equals c squared. Which gives me 5 equals c squared, and I'm going to take the square root of that. So c equals the square root of 5. Radius, square root of 5. When it's time to write the equation, do the opposite signs of the center. So x minus 2 squared, y minus 2 squared, and I need to square the radius, which then cancels out the square root and the square, leaving me an answer of 5 in my equation. For example number 9, we've got the center at -3, 1. And then we've got a tangent line. So a tangent line is when you have a circle, and then you have a line that is just barely touching it. So it could be across the top, it could be diagonally through the side, but it just kind of crosses it at one little place. Right there, right there. So we're going to make a tangent line at x equals 1. So x equals 1 would be right here. And we're going to need to make our circle. And remember, the pink dot is the center of our circle. We're going to need to make that circle large enough so that it barely touches the line right there. So if I think about it, that's the radius. So that's 1, 2, 3, 4. So I can go up 4. I can go over 4, down 4, and there's the circle. If I made it smaller, it wouldn't touch the line. If I made it bigger, it would cross through the line twice. Center was given to me, -3, 1. And we did the work that we needed in order to find the radius, which we counted as 4. And we can count this right here because it's not a diagonal. As long as you're going right, left, up, or down, you can count the blocks. And now we plug everything into the equation. Remember, we're going to change the h and the k. So +3, -1. And when we're going to put the radius into the equation, we still want to square it, 16. All right, for the last one, we have our center at 13, 12, and it's going through the points 15, 16. So they don't give me a grid because 13, 12, 15, 16, those are numbers bigger than I normally have on a regular graph. Normally my graphs go from 10 to -10. That doesn't mean I still can't sketch it out. So I'm just going to approximate this. I'm going to say 13 is right here, and I'll say 12 is right here. So I'm just going to label those. And I'm going to plot my first point at 13, 12. That's the center of the circle. Now I'm going to figure out where 15, 16 is approximately. 13, 14, 15, 12, 13, 14, 15, 16. And I'm going to plot my other point, one of the edges of the circle, the sides of the circle, as 15, 16. So imagine your circle is kind of something like that. And that blue point is on the edge of it. In order to write the equation, I need my center. I already know my center. It's that pink dot right there, 13, 12. All I have to find now is the radius. The radius for this problem is a diagonal, so I'm not going to be able to just count it. I'm going to have to use Pythagorean theorem. So I'm going to create a little tiny triangle. And based on my grid at the top and at the bottom and on the side, I'm going to be able to tell how far that is. So the pink dot was at 13, and it goes all the way here to 15. So that must be a distance of 2 from 13 to 15. Then I look at my grid on the side. This was at 12, all the way up to 16. That's a distance of 4. So now I've got my sides as 2 and 4. 2 squared plus 4 squared equals c squared. Do the Pythagorean theorem, and you'll find your radius. Go ahead and take a second, try that one. All right, so for my radius, I'm getting the square root of 20. There's no need to turn this into a decimal or break it down at all into a simplified radical. I'm just going to write it as the square root of 20 because I know my next step is going to be to square it to write it back into the equation. All right, so I'll write my equation down here because I'm running out of space. So x minus 13 squared, y minus 12 squared, and I'm going to take my radius and square it, so that way the square root and the square cancel out, and I'm just left with 20. All right, if you have any questions over that, I will be available on Friday. Hop onto the Google Meet, and we can go through some more examples.